In the deep, tropical rainforests of Australia, a wild dingo prowls through the shadows, looking for an easy meal. But its intended prey holds its ground. Instead of fleeing to the canopy, a cassowary steps forward, ready to defend itself with a swipe of razor-sharp toe claws that easily intimidate the predator. The cassowary is one of approximately 60 living species of earthbound birds spread across the globe. Yet, if you trace their lineage back, every single one of their common ancestors possessed the ability to fly. Taking to the skies offers immense biological benefits. It allows an animal to escape ground predators in seconds, hunt from a high vantage point, and cover massive geographic distances. This diagram compares the two forms of movement. On the left, aerodynamic lift requires an extreme, constant burn of metabolic energy. It enforces strict, uncompromising limits on an animal's body weight and size. On the right, walking expends a fraction of those calories. By keeping their feet planted, these animals sidestep that caloric drain. Abandoning flight allows these birds to reallocate their entire energy budget towards survival on the ground. Once the environmental pressure to fly is removed, a bird's physiology responds. Over thousands of years, the body transforms to match its new, grounded routine. Previously hollow bones fill in, becoming thick and dense for terrestrial life. Looking at the chest area of this skeleton reveals the regression of flight anatomy. The keel, where flight muscles normally attach, shrinks, and wing structures disappear entirely. This structural overhaul is especially common when birds migrate to isolated islands with no natural predators. Without the threat of being eaten, a species can ground itself in as quickly as a few generations. With their daily energy expenses slashed, these island birds survive on highly specialized, low-nutrient food sources. The takahe of New Zealand sustains itself almost entirely by grazing on the soft bases of alpine grasses. But this path comes with a fatal vulnerability. These birds lose all natural defenses against sudden changes in their ecosystem. When humans arrived on these islands, they introduced invasive ground predators, like dogs, cats, and stoats. These hunters found a landscape full of defenseless targets. The massive short-term energy savings that allowed these birds to thrive in isolation turned into an evolutionary trap, driving many species to extinction the moment their borders were breached. A second group of flightless birds faced a completely different reality. They survived on vast mainlands, directly alongside an abundance of natural predators. Unlike the island dwellers, these species evolved alongside early mammalian predators for tens of millions of years. These birds redirected their energy savings into physical size, ballooning in mass until they became far too heavy for wings to lift. This chart plots the mathematical limit of flight. As body mass scales upward, you reach a threshold where no wing can generate enough lift to carry the weight. These birds crossed this line millions of years ago, locking them onto the ground permanently. To survive down there, their lower anatomy bulked up. Their legs grew thick, their feet sturdy, and they developed dense thigh muscles designed to make them elite runners. An ostrich can leverage those physical adaptations to sprint across the open plains at speeds up to 50 miles per hour. These mainland species traded to safety of the sky for sheer physical mass and brute speed, giving them the tools to go toe-to-toe in a terrestrial arms race. Even though they weigh too much to lift off, the appendages still attached to these birds are not useless evolutionary leftovers. Many flightless species continuously repurpose their wings. They tuck their heads underneath them to conserve body heat, use them to shelter their eggs, or fan them out in wide displays to attract mates. Others took anatomical recycling to the extreme. The penguin entirely retrofitted its tick flight muscles and strong keels, turning its wings into highly effective hydrodynamic flippers for deep water propulsion. These creatures are highly specialized, efficient organisms, completely tuned to the specific demands of their environments. The decision to ground a lineage is a definitive trade-off, showing that in certain environments, the most effective way to compete is with your feet.